New breakthroughs in robotics are making it harder and harder to tell where the line between human capability and machine intelligence really lies. In just the past few days, 3 different updates have landed that paint a picture of the near future. Meta has entered the humanoid robot race with its own project. X's neo-humanoid robot just demonstrated the kind of tool use you normally only expect from people. And NVIDIA's latest robotics framework is showing how quadrupeds and manipulators can train for complex real-world physics in ways that make them startlingly capable. Put all of these together, and what you're looking at isn't just hype. It's a roadmap to machines that don't just look human, but act and reason like us in ways we've never seen before. Welcome back, everyone. Alfie here with 3 exciting updates. New AI robots has just stunned the world, and you won't believe how human-like these machines have become. As always, we're here to keep you at the forefront of the future, so let's get into it. Let's start with Meta, because this one caught a lot of people off guard. Meta, the company everyone associates with social platforms like Facebook, Instagram, and of course its giant bet on the metaverse, is now officially developing its own humanoid robot. According to reporting from The Verge, the project is called MetaBot. At first, this might sound like another tech giant dabbling in robotics, but here's why it's a lot more serious than that. Meta already has some of the most advanced AI models on the planet. Think about their large language models like LLA-MA, their breakthroughs in generative AI, and the massive compute infrastructure they've built to train these systems. Now imagine taking those models and plugging them into a humanoid form. The potential suddenly jumps off the page. For years, people have wondered what the killer app for Meta's metaverse obsession might be. Headsets, virtual spaces, digital avatars? But what if it's not any of those things? What if it's robots that can exist in both the physical and virtual world? A MetaBot could act as a physical avatar for you in real life while also being fully connected to Meta's digital ecosystem. You could literally be present in a virtual office with your colleagues, while your MetaBot does chores around your house. That isn't sci-fi anymore. It's the natural extension of everything Meta's been building. The report from The Verge didn't go into every technical detail, but it was clear enough. Meta isn't entering this space lightly. They're putting real money and talent behind MetaBot. And if we think about the competition, Tesla with Optimus, Figure with Figure 02, 1X with Neo, and Chinese players like Unitree and Fourier, it suddenly makes sense why Meta would want its own stake in humanoids. This is shaping up to be one of the biggest technology races of the decade, maybe even bigger than the smartphone revolution. Now, speaking of 1X, that brings us to the second jaw-dropping update. Their humanoid Neo just did something deceptively simple, but deeply important. It used a vacuum cleaner. And no, not as a pre-programmed cleaning bot. We're talking about a humanoid robot picking up a vacuum designed for human hands and operating it the way a person would. This might not sound flashy at first glance. After all, we've had Roombas for decades. But here's the crucial difference. Roombas are built for robots. A vacuum cleaner in your closet is built for humans. It's heavy, it has triggers, angles, cords. It's awkward to use unless you have hands and human-like dexterity. So when Neo grabs a vacuum and uses it, what you're seeing is a glimpse of what general purpose really means. These machines won't just operate in factories with customized tools or in controlled environments. They'll use the exact same household appliances, cleaning gear, and work equipment that you and I already own. No special design needed. That's the leap. And it ties directly into the larger conversation around embodiment. If robots are going to be truly useful in human environments, they need to master our tools, not just their own. Seeing Neo vacuum a floor is one of those quiet moments in robotics where you realize this isn't a gimmick. This is the start of robots blending seamlessly into everyday spaces, not by replacing objects, but by adapting to the world we've already built. And here's something else to think about. 1X is already known for its big ambitions. Their earlier robot, Eve, is still rolling around offices and homes in Norway, doing work like security patrols. With Neo, they've gone full humanoid, and this vacuum demo proves they're serious about autonomy and dexterity. The company is building towards robots that don't just look the part but can truly live alongside humans. But all of that capability, humanoid forms, dexterity, learning, depends on training. And that's where the third piece of news fits in perfectly. NVIDIA just unveiled new training environments through Isaac Lab, their simulation platform for robotics. Two of the highlights are training a quadruped locomotion policy and simulating cloth manipulation with Newton physics. Now, if that sounds technical, let's break it down into why it matters. Quadruped locomotion is basically how four-legged robots learn to walk, climb, or adapt to complex terrain. Dogs, cats, horses, they move with incredible balance and efficiency. Teaching robots to do the same has always been a huge challenge. But with NVIDIA's new policies, robots can learn these skills in simulation at massive scale before ever stepping into the real world. That cuts down development time, improves reliability, and allows for environments that would be too dangerous or expensive to test physically. Imagine a quadruped robot being trained to walk through rubble after an earthquake or trek across uneven construction sites. With these policies, you can simulate all of that first and then transfer the skill directly to the hardware. Then there's cloth manipulation. This is another frontier that seems small on the surface but is incredibly important. Folding laundry, tucking in sheets, tying knots, these are all examples of interacting with cloth. For robots, this is one of the hardest problems in manipulation because cloth doesn't behave like a rigid object. It folds, creases, slides, and reacts unpredictably. NVIDIA's new cloth simulation with Newton physics means robots can now practice these tasks in ultra-realistic virtual environments until they get good at it. And once they're good, they can take those skills into the real world. Think about how this ties back to the other updates. If 1X's Neo can already vacuum like a person, imagine what happens when training environments like NVIDIA's give it the ability to fold your laundry or make a bed. That's not decades away anymore. That's the logical next step. And for Meta's Metabot, the synergy is obvious. A company like Meta could easily leverage NVIDIA's simulation frameworks to train its humanoids faster, making them competent in household and workplace tasks right out of the box. Suddenly, you're not just buying a robot. You're buying one that has already mastered thousands of hours of simulated chores before ever stepping into your living room. The connective tissue between all of these updates is this: robotics is no longer about one-off party tricks. The days of robots doing a backflip just to grab headlines are fading. What we're looking at now is practicality. Robots using our tools. Robots training for our environments. Robots entering our ecosystems, backed by the biggest tech companies in the world. And here's where it gets even more interesting. Each of these players, Meta, 1X, NVIDIA, brings something unique to the table. Meta brings massive AI research and social integration. 1X brings real-world humanoid deployment and hardware expertise. NVIDIA brings the simulation horsepower and physics modeling. Combine those elements, and you start to see the skeleton of an industry that is moving way faster than anyone predicted. We're not just inching closer to general-purpose humanoid robots. We're sprinting toward them. And the moment one company puts all these elements together, dexterity, reasoning, training, and integration, you'll have robots that can not only do tasks but learn new ones on the fly, just like we do. Now let's pause here and imagine the ripple effects. In homes, you'd see robots able to handle cleaning, cooking, and caregiving without requiring new appliances. In offices, you'd have assistants that aren't just virtual voices, but physical presences, capable of handling logistics, moving equipment, and setting up spaces. In industries, robots could train virtually for dangerous jobs before being deployed, reducing risks for human workers. And in healthcare, imagine humanoids trained to assist with delicate tasks like dressing wounds or moving patients, trained not in trial and error with real people, but in endlessly repeatable simulations. All three of these updates signal one clear trend. The line between human-like and human-useful is blurring. When Meta, 1X, and NVIDIA are all pushing in the same direction, it's no longer about whether humanoids are coming. It's about how soon and who gets there first. The most stunning part isn't any single demo. It's the fact that we're starting to see convergence. Humanoid robots that use human tools, AI frameworks that let them reason and plan, simulation systems that prepare them for the messy, unpredictable real world. These aren't separate breakthroughs, they're pieces of the same puzzle. And once those pieces lock into place, the machines that emerge on the other side will feel less like tools and more like colleagues. Too human to believe? Maybe. But from Metabot's entry into the race, to Neo vacuuming your living room, to NVIDIA's robots folding laundry in simulation, it's all happening right now. The world is being stunned not by science fiction, but by science fact. And this is just the beginning. Gemini AI has just taken a step that could change robotics forever. Google's Gemini 1.5 models are no longer just powering chatbots, search assistants, or productivity apps. They're now driving actual robots, and not in the limited, pre-programmed sense we've seen before. These robots can reason step by step, plan ahead, use digital tools like search, and even transfer what they learn from one kind of robot to another. That last part is huge, because it means we're closer than ever to general-purpose robots. Machines that can work in real-world settings the way humans do, not just in carefully staged demos. The first big breakthrough here is reasoning. In the past, robots, even the advanced humanoids we've seen from Tesla, Figure, or Boston Dynamics, relied on separate control systems that translated commands into physical motions. They could walk, pick things up, or follow specific instructions, but they didn't actually think through the problem like a human would. With Gemini 1.5, that's different. The robot doesn't just hear a command like "sort the laundry" and blindly start moving. Instead, it pauses to plan. You can literally see its thought process as it breaks the task into steps. Identify the clothing items. Determine which pile they belong in. Move each item accordingly. And only then does it begin acting on those steps. This is the closest we've seen to a robot engaging in actual reasoning, deciding what to do before it starts moving. That distinction matters. It's the difference between a robot that's basically a programmable arm and a robot that can operate in unpredictable environments. A washing machine can wash clothes, but it can't figure out what belongs in the wash in the first place. A Gemini-powered robot can. Another stunning piece of this breakthrough is that all the robots are using the same underlying Gemini models. Whether it's Apollo, Google DeepMind's humanoid research platform, or smaller platforms like Aloha and the Biarm Franca, they're all plugged into the same brain. Normally, robotics is siloed. One robot might be great at manipulation tasks, another at walking, another at navigation. Training each one takes time, money, and huge amounts of data. But Gemini 1.5 is showing something new, a kind of transferable intelligence. What the robot learns in one setting can be applied in another. If Apollo learns how to fold a towel, Aloha doesn't need to start from scratch. It can inherit that knowledge through the shared Gemini backbone. This is exactly how humans operate. Once you learn how to solve a puzzle, you can apply that logic to different but similar puzzles. This makes robotics far more scalable. Instead of building narrow, task-specific bots, companies can finally move toward general-purpose helpers that adapt to multiple environments without retraining every time. Now here's where things get really wild. Gemini-powered robots aren't just limited to their onboard sensors and preloaded instructions. They're gaining agentic power. That means they can use digital tools, like search, to solve problems in real time. Imagine asking a robot to cook you a meal it's never made before. A traditional robot would fail because it only knows what it's been trained on. A Gemini robot could search for the recipe online, read through it, break it down into step-by-step instructions, and then execute those instructions in your kitchen. This isn't science fiction. Google is already demonstrating that these robots can query the internet to fill in their gaps. If they don't know how to do something, they can look it up. That's the same skill that makes humans so adaptable. We don't memorize everything. We rely on external tools, whether that's Google, YouTube, or a good old-fashioned cookbook. For robots, that's a line we've never seen crossed before. They're no longer just pre-trained machines. They're becoming active problem solvers. When Sundar Pichai took to X to share the video of Gemini robotics, it wasn't just a casual update, it was a statement about the direction Google sees the future heading. Pichai highlighted that these new models are capable of reasoning step by step before acting. That small phrase, step by step, might sound ordinary, but in robotics, it's groundbreaking. Because step-by-step thinking is what separates mindless execution from true intelligence. Think about it. Humans don't just react. We pause, plan, and then act. That's what makes us effective at handling messy, unpredictable environments. For decades, robotics has struggled with this. A robot might be great in a controlled demo, but useless in the real world because it can't improvise. Gemini's step-by-step reasoning is the missing ingredient that could change all that. Let's talk about that demo video. On the surface, it shows a Gemini-powered robot sorting laundry. Cute, right? Not exactly groundbreaking. We've seen robots fold shirts before, but the point wasn't the laundry. The point was how the robot approached the problem. Instead of following a hard-coded routine, it actually thought through the task. It considered each item, reasoned about what to do with it, and executed based on its own plan. That's fundamentally different from a pre-programmed demonstration. Laundry was just the test case. The real message was, if robots can reason their way through sorting laundry, they can reason their way through 1,000 other unpredictable household or workplace tasks. And that's the holy grail of robotics. Robots that can adapt, not just repeat. This breakthrough pushes robotics toward the vision everyone's been chasing: general-purpose robots. Right now, most robots are specialized. A warehouse robot moves boxes, a delivery bot carries packages, a hospital robot delivers medications. Each is locked into a narrow role. But if Gemini 1.5 can truly reason, plan, and transfer knowledge across platforms, the future changes. Suddenly, you don't need 10 different robots for 10 different tasks. You need one adaptable robot that can learn, search, and figure things out as it goes. That's why this is being called a line-crossing moment. We've officially stepped out of the era of dumb, specialized machines and into the dawn of adaptable, intelligent agents. Let's drill down on transfer learning for a second, because this is one of the most powerful parts of the Gemini robotics project. Traditionally, teaching a robot to do something new is expensive. You need hours of training, data collection, and fine-tuning. And once you're done, that knowledge stays stuck in that one robot. With Gemini, that wall comes down. When one robot learns a skill, others can inherit it through the shared model. This is exactly how humans scale knowledge. One person figures out how to invent fire, and suddenly the entire community benefits. One person writes a manual, and millions can learn from it. That's the level of scalability Google is hinting at here. It means progress in robotics will no longer be siloed experiments. It'll be a collective climb toward general-purpose intelligence. Another reason this breakthrough matters is that Gemini robots aren't just reasoning, they're using tools. And tool use is one of the hallmarks of human intelligence. Anthropologists often point to tool-making as the defining leap that separated humans from other primates. Now we're watching robots cross that same threshold. They're not just moving their own arms. They're reaching into the digital world to pull in extra resources. A robot that can Google instructions, or tap into a calculator, or analyze a map online is exponentially more powerful than one that can't. This agentic ability is how we move from robots that just do to robots that actually solve. Make no mistake, this isn't just a nice academic demo. This move shakes up the entire robotics industry. Companies like Tesla, Figure AI, and 1X are all racing toward a GI-powered humanoids. Their demos have been impressive, walking, grasping, manipulating. But until now, none of them have shown robots with true agentic reasoning tied to internet tools. Google just showed it, and that gives them a massive advantage. Think about it. Tesla Optimus may have cutting-edge hardware, but if Gemini robots can think, plan, and search in real time, Google just leapfrogged the competition in intelligence. And in robotics, intelligence is what will ultimately decide who wins. Hardware can be copied. Reasoning ability is harder. All of this leads to one huge question. Are we ready for robots that can plan, reason, and use tools like humans? Because this isn't just a technical leap, it's a societal one. Robots that can independently query the internet and reason through problems are much closer to autonomous agents than to simple machines. That raises questions about safety, alignment, and control. If a robot can search the web and take action, how do we ensure it only uses safe sources? If it can transfer skills across platforms, how do we prevent dangerous knowledge from spreading? And if it can plan step by step, how do we make sure those steps always align with human goals? These are the debates we're going to see more of in the coming months. Because the technology is already here. The question is how we choose to use it.